A very good morning, all the students. I am Dr. Meghabriti Pramanik, Assistant Professor of Haldia Institute of Technology in Electrical Engineering Department. So today I will start about power system transients. Before going to what is power system transients, I will discuss about what is steady state of the system. So, when system is in steady state, the system is operated or system can be modeled in nonlinear algebraic equations. Okay, and after when system is in steady state and when we are applying small scale of dynamic perturbation, then what happens? The system remains in its steady state point, and at that time system can be modeled using linear differential equations with constant parametric values. But when system is in abnormal condition and when we are applying a large type of perturbation, that means in case of steady state we have applied small scale of dynamic perturbation, and in when the system is in abnormal condition and we are applying any perturbation which is large scale of perturbation, that means which is due to the fault, opening or closing of a switch or large scale of disturbance, at that time system goes to the abnormal situation or transient occurs. Okay, and transient phenomena last in the power system for very short period of time, which is ranging from a few microsecond to up to 1 second. This table represents the transient phenomena and frequency spectrum. Here, the left hand side represents the phenomena and right hand side represents the frequency range. Okay, the first one is the ferroresonance, which lasts for 0.1 Hz to 1 kilohertz frequency range. After that, load injection, that means when we are injecting any current, okay, or that means when we are injecting any current in the power system bus bar or any power system grid, at that type of case the frequency range is 0.1 Hz to 3 kilohertz. After that, fault clearing, this is also one type of transient phenomena, because at that case what is happening? Fault clearing, that means we are clearing any fault and at that time certain disturbances is also creating. Okay, so fault clearing, at that case the frequency range is 50 Hz to 3 kilohertz. Overhead transmission line switching, which is 0.1 Hz to 20 kilohertz. Okay, after that, transient recovery voltage, which lasts for 50 hertz to 100 kilohertz, and last one is the lightning induced over voltage, 10 kilohertz to 3 megahertz, and last one is the switching in gas insulated substation, which is 100 kilohertz to 50 megahertz. This slide represents the time frame of power systems transient phenomena. And here, in the previous slide, whatever I have shown you, this is the phenomena versus frequency range. And here, this is showing the phenomena versus time lapse. Okay, that means for how many times or for how many time stamp this incident occurs. Previous one was the frequency range and this one is the x-axis represents the time occurring or time of the events, okay, which is in second. And if we see that the 10 to the power minus 7 up to 10 to the power minus 5, within this, that means this is the very small, very small time range, and at that time the switching in SF6 substation is occurs. That means this is the very fast transient, that means time duration is very small, very small. And if we go to the right side, then we see that the lightning strike and switching, all this happens in the range of 10 to the power minus 4. Lightning strike, we can see that it is happening for the 10 to the power minus 6, from 10 to the minus 6 to it is going to the 10 to the power minus 4. Okay, that means it represents the very first transient to first transient, that means the lightning strike. Okay, similarly the switching, that means the switching on or off the switch. Okay, that means any switching operation, this is also in the very fast transient to up to the first transient. Okay, this is the switching. And if we go to the 10 to the power minus 3, 10 to the power minus 1 in this range, that means this is the transient. Okay, these are also the transient, but as per the time duration, we just categorize this as the very first transient and so on. These are all the normal condition. That means the when situation is in the dynamic case. Okay. And here we can see that the lightning strike and switching, they represent within the 10 to the power minus 6 to 10 to the power minus 4 and 10 to the power minus 3, and this is 10 to the power minus 1 within this range. That means the switching operation from fast transient to transient. Okay, but lightning strike is the very fast transient to fast transient. Okay, and similarly we can, if we go towards the right, then we can see that the transient stability, this is the 10 to the power minus 1 to 10 to the power 1, that is 10 second, and very long term dynamic, this is within the range of 10 to the power 3 to 10 to the power 5. This is the long term dynamic. That means this is not like the transient case, this is the system dynamics. Okay, that means the system is in dynamic condition. And governor and frequency control, this remains in the range of 10 to the power minus 1. That means somehow for certain moment transient occurs in the governor and frequency control, which is 10 to the power minus 1 to up to 10 to the power 2. Okay, within this range. So now I am going to the transients in the electrical circuit. So at first, before going to the transients in the power system, now I am coming to the transients in the electrical circuit. Electrical circuit means, that means this is the resistive and inductive circuit, RLC, RLRC. In that combination, what happens in that of circuits? Okay, so whenever the electrical power is supplied to a circuit and which changes momentarily over a short duration of time, this is called the transients. Okay, that means when there is the change in electrical power supply. Okay, that means certain change, that means when switching is on and off, that means there is a drastic change in the power. Okay, so how can I represent this one? So in any electrical circuit, that means if I am representing is as a sinusoidal signal, that means when the system is in steady state, then its time or its waveform or its representation when the any circuit or any system is in steady state case, then we can represent it by this sinusoidal waveform. Okay, so when any energy changes energy or any perturbation is applied, then there the transient occurs, which is very momentary change. That means the at t equals to t1, suppose the perturbation is applied or change in energy, so there is certain change in the system. Okay, so there is certain change or there is sharp peak. We can see that here, this is the normal trend of the waveform, which is 0.5. Okay, and it went up to 1.2 if this is scale is in per unit, and this is the second. Okay, this is in second and this is in per unit. So we can see that the magnitude is going up to from 0.5 to 1.2. Okay, but the normal range is up to 1.1. It goes to the up to 1.2. So we can say that the transient is occurs at t1 time frame. Okay. So there is the certain change in the circuit and we can say that the transient is occurred. Okay, and similarly for the AC circuit and DC circuit, the transient may occur, and which are the equally vulnerable. That means AC circuit and DC circuit both are the equally vulnerable. and the steady state values are reached after the transient period. That means if the system goes to the steady state, whatever I have shown at that figure, so we can say that the steady state goes, that means here at t1 time frame, at t1 time frame the transient occurs, and when the transient goes or transient diminishes to zero value, okay, here the transient diminishes, that means at t by 2, if the total time period is t, at t by 2 time period it goes to 0. So the steady state value is reached after the transient period is over. When there is switching action in an electrical circuit, the voltage and current goes through a transient before it attains the steady state condition. So similarly, with respect to this point, we can say that the second point one is that when there is switching action, the voltage and current also changes, and after the transient, when the transient is going to zero value, after that the steady state condition is coming. Okay, and according to ANSI standards, the transient duration is 1 by 16 times the time period of the voltage and current waveform, that is about 1 millisecond. That means from here you can see that the how very small or how fast is the transient. Okay, sorry. And the voltage transients last for 50 microseconds and the current transient occurs about 2 microseconds. Okay. Here, the transient in the electrical circuit occurs for the very short duration, that means which is in the some millisecond, okay, and the duration of the microsecond to millisecond and depends on circuit parameters. That means whatever the value and nature, also the value and nature of the RLC parameters upon these or depending on the circuit parameters, the transient depends, okay, and the magnitude of the transient voltage and currents keep changing quickly until the steady state attains. Transients indicate the instability of the system. Similarly, we can say that if the system does not come to the steady state value, so we can say that the during the transient or after the transient, when it is goes to the unstable condition, or it is not coming to the initial state, so we can state that the system becomes unstable. That means when transient occurs, this circuit, that means the electrical circuit, that means which composes of RLC, this circuit goes to the unstable state. Okay, that means, so we can say that then here is the term which is coming, that means the controlling of the transient. So controlling of the transient, which is becomes very much important for the system reliability purpose. Now coming to the energy of the transients. Okay, so energy is generated. So we can say that when transient occurs in any electrical circuit means, that means when there is change in energy. Okay, that means the change in energy means the energy may be additive or it may be subtractive. Okay, so when the transient occurs and when there is the excess amount of energy, this may be in additive or subtractive in nature. So this can be added or subtracted to the normal or nominal waveform energy. That means when the system is in steady state, okay, whatever its energy, with this energy, the energy of the transient is maybe added or subtracted depending upon its nature. Okay, so now coming to the generally additive energy is experienced with the rise in voltage or current several times greater than the nominal steady state value. So in case of when the energy is generated by means of transient, so we can say that the voltage or current by means of voltage and current, its value is several times greater the nominal values. Okay. So under transient condition, it becomes very difficult for a circuit to withstand this such lump or this such huge amount of energy. Okay, so that means when the voltage spike, that means voltage spike or current spike means what? So when there is this type, this is known as spike. Okay. So when there is maybe this is the voltage waveform. Okay. So whenever the transient occurs due to the change in energy, so that we can say that the sharp peak is occurring. Okay. So the sharp peak is occurring. That means the energy which is generated, which is very much several times. Okay. This is the several times higher than the steady state energy. So the energy, if this energy is additive in nature, so we can say that the in when system is in steady state, whatever its energy, and when the transient is occur, its energy which is several times higher than the steady state energy, this is added. Okay, so this is added means due to the spike of current or surge in the current. So the system, that means RLC circuit or any electrical circuit, has to also withstand this high energy. Okay, so there may be the malfunction of the, so we can say that the malfunction of the circuit. Okay, so the transients are also associated with the abnormal change in frequency, which can goes up to the 5 megahertz. Okay, so coming to the next slide. Okay, types of transients in the electrical circuit. Okay, one is the impulsive transient and another one is the oscillatory transient. Okay, so according to IEEE 1159 standard, impulsive transients are sudden transient disturbances of non-powered frequency that are unipolar in nature. Okay, and due to the lightning, this impulsive transient may occur, and this impulsive transient is characterized by the rise time, decay time and spectral content. Okay, so what we can say that what is impulsive transient? So what is impulsive transient? So impulsive as per the IEEE 1159 standard. Okay, that means we can say that IEEE has binded some standards, and as per 1159 standard, we can say that when there is only one spike, that is either it may be positive or negative. This is the positive spike. Okay, this is the positive half cycle. Okay, this is the positive half cycle and this is the negative half cycle. So when there is in the positive high cycle, when there is positive spike, or in the negative half cycle when there is negative spike, this is known as impulsive transient. Okay, but simultaneously it does not, it may occur positive or negative, only positive or only negative at a time it may occur, then it is known as impulsive. Okay, that means the sharp spike, that means it is the sharp spike. Okay, this is known as impulsive, and in case of lightning it occurs. And what is oscillatory transient? Similar to the impulsive transient, oscillatory transient is also the spike it occurs, but this has the two poles, that means the positive polarity, and in the negative side there is also the negative polarity. This is known as oscillatory. That means, more precisely, so more precisely we can say that when there is when there is any perturbation is occurring and there is the positive and negative half cycle in the waveform, so this is known as oscillator. That means this is oscillating in nature, and in case of impulsive this has one spike, only one spike. That means it may be positive or may be negative. Okay, but here we can say that the oscillatory, that means if we make the envelope, so we can say that the this type of situation is occurring. Okay, that means this is the oscillatory transient. Okay, so the oscillatory transient is covered by the magnitude, duration and the spectral content. Okay, and the polarity of the oscillatory transient is either maybe positive or negative, and it changes very fast. And going to the next slide, and this is the classification of transients based on the frequency. Okay, so from here we can say that this is the classification and this is the duration type. Okay, so we can see here this is the low frequency, medium frequency and high frequency, and there are two classes. One is impulsive transient and another one is the oscillatory transient. So low frequency, which is greater than 1 millisecond, and medium frequency, which is 50 nanosecond to 1 millisecond, and high frequency, which is less than 50 nanosecond for in case of impulsive. If this is impulsive and this is the duration, but in case of oscillatory transient, for low frequency it lasts for 0.3 to 50 millisecond, medium frequency up to 20 nanosecond, 20 up to 20 microsecond, and for high frequency it is up to 5 microsecond. That means impulsive transient duration is very less, and oscillatory compared to impulsive its duration is more than, it is going to the range up to microsecond. Okay, where for impulsive it's going to the nanosecond range, and oscillatory it goes to the microsecond range. And here are the internal and external sources of the transients. Internal sources are the capacitor switching. Second one is the when the operation in the power semiconductor switches, internal faults, electrostatic discharges, relay operation, circuit breaker and switch gear operation, load removal or addition and RT. And external sources are the lightning, external load removal or connection, operating or closing the switch gear in energized system, that means opening or closing of the switch gear in the energized system, switching of capacitor band, tap changing transformer, loose connection at the utility and end, external faults, human errors, short circuits caused by the animals, bad weather condition and neighboring circuits.